Greetings Dr. Aimi and everyone that will be watching this video. I am Vanessa and today my group and I will be presenting our lab report regarding on making biodiesel from used cooking oil. Before we start, we would like to give a big thank you to the source of our used cooking oil that is given from the Auntie Canteen at MRSM Jali. Thank you, Auntie. With that, let us start from the introduction.
Thank you, Vanessa. Let's begin with the introduction. Biodiesel is defined as fatty acid methyl ester produced through the trans-esterification of triglyceride, which can be derived from vegetable oil or animal fat. Trans-esterification is the most common process. In this process, an ester compound is exchanged by an alcohol in the alkyl group. Biodiesel will be synthesized from used cooking oil as it contains saturated triglyceride, composed of glycerol and fatty acid ester. Next, let's discuss our objectives. The primary goals of this experiment is to produce a cost-effective, renewable, and clean-burning biodiesel from used cooking oil. Additionally, we aim to determine presence of biodiesel produced based on its flammable state.
For the method in the experiment is 500 ml of used vegetable oil, 4 grams sodium hydroxide, 100 ml of ethanol or methyl alcohol, hot plate laser, beaker in 1 liter, thermometer, magnetic stirrer, digital scale to accurately measure 3.5 grams, separating funnel, aluminum foil, safety glasses, gloves, and probably a lead coil, cloth filter to filter out any suspended material in the cooking oil before use, and lastly, method for test is petri dish, cotton ball, and lighter. Next, for the methods, 100 ml of methanol is poured into a glass beaker. Then 4 grams of sodium hydroxide is added slowly. Through the mixture, sodium hydroxide can be produced and it is used immediately so that its effectiveness is not lost. Methanol and sodium hydroxide are mixed using a magnetic stirrer until the sodium hydroxide is completely dissolved, about 3 minutes. At the same time, the cooking oil that has been used has been filtered using a cloth filter to filter any suspended matter in the cooking oil before use. And then next, 500 ml of oil is heated to a temperature of 50 until 55 degrees Celsius, and each change in temperature reading is checked and controlled so that the boiling point temperature of methanol is controlled below 150 until 135 degrees. Then the mixture of methanol and sodium hydroxide is added to the heated oil. Then the mixture is mixed on low speed for 20 minutes. Once finished, the mixture was poured into the separating funnel. Through observation, there is a liquid that begins to separate into layers. The mixture is left for 24 hours to see the bottom layer become glycerin and the top layer become biodiesel. This mixture takes a maximum of 6 hours to separate completely so that it can retain the top layer as biodiesel fat. After being left for 24 hours, the biodiesel is washed or rinsed with warm water 2 until 3 times. Next, the biodiesel is heated at around 100 degrees Celsius to evaporate any remaining water, and finally test the biodiesel in the pumps. Technical notes in this experiment is read the warning labels on both the chemical containers, which are methanol and sodium hydroxide, before using them because the substances are toxic. And other than that is be careful in using methanol and sodium hydroxide by using gloves so that the substance does not reach the hands because this substance is easily absorbed through the skin and can cause students to burn chemically. And then provide biodiesel in an area with good ventilation. This is because if any chemical are spilled on the skin, we can rinse with water immediately. Next is using the usual ratio for biodiesel: 1 liter of used cooking oil, 3.5 grams of sodium hydroxide, and 100 ml of methanol. In addition, prepare biodiesel at room temperature, which is in 21 degrees Celsius or in a warmer room. This is because the chemical reaction will not proceed to completion if the temperature is too low. And then label all containers as a toxic only used to make biodiesel so that no one will drink the supply, and avoid using glassware for food again. And lastly is filter the user's oil using a cloth filter to remove any suspended matter in the user's cooking oil.
So I'll be explaining about the results. As we can see that the result was successfully obtained. After 24 hours of biodiesel production from used cooking oil, the biodiesel and glycerin were clearly separated. The top layer, which was made of biodiesel, was successfully filtered using numerous washes of warm water. The final biodiesel ignited smoothly by doing a combustion test, and it produced minimal smoke, indicating the presence of biodiesel. So the key to this good outcome was to keep the reaction temperature below methanol's boiling point and ensure that the sodium methoxide was thoroughly mixed with the heated oil. This outcome shows that the experiment successfully produced biodiesel corresponding with the objective that was specified in the experiment. Thank you.
I'll be presenting for the discussion part. So firstly, while biodiesel was produced, the biodiesel and glycerin have been effectively separated after 24 hours. But even though the two layers had been separated, the process only achieved at 90% approximately, and since that we have to filter the biodiesel from the excess unwanted contaminants before washing it. And then a clean burning field was indicated by the combustion test producing barely any smoke and burning for a long period of time. Effective trans-esterification was made possible by keeping the temperature below the boiling point of methanol and making sure that the sodium methoxide and the oil were completely mixed. Several improvements could have been done, such as better temperature control throughout the process would have ensured more consistent result. More thorough steering and possibly a longer reaction time might have improved the completeness of the trans-esterification, and the pre-treating the used cooking oil to remove impurities like food particles, water, could have resulted in a purer biodiesel product. Furthermore, the extending the washing process would have helped to remove more residual methanol and other contaminants that can lead to a cleaner burn for the combustion test. And lastly, the possible mistakes of factors such as the leftover contaminants in the cooking oil, uneven temperature management, and insufficient dissolving of sodium hydroxide can give an impact on the biodiesel output and purity.
I will present my part for lab report of this experiment, which are questions and answers and also conclusion. For the questions and answers, the first question is, which layer consists of biodiesel? How do you recognize it? The answer is, the layer that consists of biodiesel is the top layer in the separating funnel after leaving it about 24 hours. Biodiesel can be recognized because biodiesel is less dense than glycerin, so that it will cause the biodiesel to float above the denser glycerin layer. Next, question number 2. How to prove the consistency of biodiesel? To prove the consistency of biodiesel, heat to around 100 degrees Celsius to evaporate any residual water. Then, do a combustion test by applying a small amount of biodiesel to cotton, placing it in a petri dish, and using a gas lighter to flame it. If it flames and burns consistently without producing excessive smoke, it confirms the existence of biodiesel. And for the last question is, what is the reaction and process involved between the mixture of methanol and AOH and used cooking oil in biodiesel? The reaction involves the trans-esterification process, where triglycerides in the used cooking oil react with methanol to produce sodium methoxide in the presence of sodium hydroxide and AOH as a catalyst. This reaction breaks down the triglycerides from used cooking oil into glycerin and methyl esters, and then it forms biodiesel. The process involves heating the mixture, separating the biodiesel from the glycerin, and allowing it to react. Then, for the part conclusion. In conclusion, the experiment aimed to produce biodiesel from used cooking oil through the trans-esterification process. The experiment successfully converted the used cooking oil into a clean burning biodiesel layer, separating it from glycerin. The proven from the combustion test, which confirmed the biodiesel's consistency, thereby the objective of producing a renewable and cleaner fuel was achieved. This experiment confirmed that biodiesel may be effectively produced from used cooking oil, which aligns with the goal of sustainable energy solutions. Thank you.